Hello everyone, my name is Artul and welcome back to another video in our series of artificial intelligence and deep learning. Today we'll be talking about AI agents and I will be basing my video on a few videos from codebasics and one from IBM Technologies. So as usual, I have them linked down in the description if you guys want to check it out. Anyways, starting, let's talk about AI agents. Let's um start off with recursion and iteration. So these are two common approaches in programming. Let's break them down. Recursion is when a function calls itself in order to solve smaller instances of the same problem. Think of it like peeling an onion, layer by layer, until you reach the core. It's often a go-to method for problems that can be divided into smaller, similar problems, like navigating a file system or working with trees and data structures. On the other hand, iteration is the process of repeating a set of instructions using loops. It's generally more efficient than recursion because you don't have overhead of function calls. Iteration is perfect for problems like traversing through a list of items or performing an action multiple times, like adding values or counting occurrences. So they both have their advantages, separately, but as you might guess, the choice between recursion and iteration depends on the problem you're solving and the system's resources that you have at hand. Next up, let's talk about stacks. So stacks are a fundamental data structure in computer science. They follow a last in first out principle. What this means is that the most recently added element is the first one to be removed. So picture a stack of plates at a buffet. You grab the top plate first and you add new plates to the top. Stacks are incredibly useful for solving problems that require a sequence of operations, like evaluating expressions or managing function calls in a program. One classic example is how recursion works. Each function call creates a new stack frame that gets popped off once it's completed. The idea of stacking is a powerful way to manage the flow of execution and data. So mathematically, stacks help us manage the state of computations or keep track of elements in a certain order, which makes them essential for many algorithms such as depth first search in graphs. Now let's continue with the fundamental concepts that we've so far learned. So next up is word embeddings. So word embeddings are a way of representing words as vectors, basically turning words into numbers, similar words are close together. This technique allows machines to understand relationships between words, like recognizing that cat and kitten are related. So these concepts are all about how machines understand and generate human language. One of the most powerful tools for working with language is the transformer model. Transformers are designed to handle sequential data like language, and they're responsible for many of the breakthroughs in machine learning today. They use a mechanism called attention, which allows them to focus on different parts of the input data all at once, making them highly efficient at processing long sequences of text. Transformers have revolutionized fields like machine translation, text generation, and even chatbots, enabling systems like GPT, BERT, and others to generate coherent, contextually aware text. The combination of word embeddings and transformers have created some of the most advanced AI models we've seen today. We can, see this with ChatGPT, DeepSeek, Claude, Copilot, Gemini, and many others that, to be honest, I'm forgetting about. But the combination of word embeddings, it's why AI can now generate human-like text. So it can also translate languages or, summarize documents for us. Now let's quickly recap hyperparameter tuning. So if you've worked with machine learning models, you know that choosing the right settings can make or break your model's performance. Hyperparameters are the settings you manually configure before training a model, like the learning rate, the batch size, and the number of epochs. These values control how the model learns and how long it takes to train. Finding the right combination of hyperparameters often requires experimentation and can be time consuming. That's where the techniques like grid search or random search comes into play. Grid search tries all possible combinations of hyperparameters, while random search picks combinations randomly. The goal is to find the best combination that leads to the highest accuracy or performance. This process is crucial, especially when training complex models like deep neural networks, where small changes in hyperparameters can have a large impact on the results. So, just as a quick summary, as to what we've learned today, and we've recapped. We explored recursion versus iteration, the power of stacks and data structures, and how word embeddings and transformers are revolutionizing natural language processing, and also how hyperparameter tuning specifically helps fine tune machine learning models. With that recap out of the way, let's take a look at a simple agent that I made. So this is based on one of codebasics videos on a tutorial of AI agents. So as usual, that'll be linked down in the description. But this is a slightly modified version of what he showcased in his video. This isn't using multi-agent agents. I couldn't get that to work uh because of OpenAI. The any all the what's called all the imports that I wanted to use all the tools from, specifically fee data, because that's what we're using here, required me to have a OpenAI API key, and I had to run out of um, requests on my end. So we're sticking strictly to Grok here. That's using um, Llama, specifically Llama 3.3 70B. Um, but yeah, we're using Wi-Fi Finance as one of the tools. Like I said, it's not using multi agents, but let's run this and see what it gives us. So this is using Y Finance to get the stock prices of the top 10 richest companies by net worth, and then I told the AI to compare the top two companies. So let's take a look at the output. So, actually, before we take a look at the output, I told it to use Markdown, and I told it to use tables to display the data. So that's why it looks neat like this. We also have dot environment imported here to import my API key into a dot environment file. That's so that I don't have my API key just imported into the code here. I wouldn't want that. I wouldn't want somebody else to see that. And then we just have show tool calls so we can see what kind of calls the AI makes whenever it tries to retrieve this data. So let's take a look at this. So this is the tool calls that it runs. So get current stock price symbol, the symbols, get stock fundamentals, those symbols as well. Okay, top 10 richest companies by net worth. The following table displays the stock companies of the 10 richest companies by net worth. Please note that the list of the top 10 richest companies may vary depending on the current market situation. So it put rank one Berkshire Hathaway and number two Apple Inc. So it seems to be having issues right now with okay. Oh wait, no. Okay, I see. It's because I told it to compare. So let's change it a bit. So this is it comparing Berkshire Hathaway and Apple. So let's take away this part and let's run it again and see what the output looks like. Should look quite different. Okay, so here we go. We have more tool calls here. So and then it tells us the top 10 richest companies in the world by net worth along with the current stock prices. So we have Berkshire Hathaway, Amazon, Microsoft, Alphabet, Inc., which is Google, Google's parent company. There's Apple, there's Meta, there's Tesla, there's Toyota, there's Walmart, and Johnson and Johnson. So not it's not giving us the stock price for Berkshire Hathaway for some reason, but other than that, we have all the net worth available here and also the current stock prices. So the net worth values are in trillions or billions of dollars. The values may fluctuate, because the stock market is always changing, and the stock prices are subject to change and may not reflect the current prices. Yep, that all checks out. So the AI agent here, in a simple API call, answered my question, provided me what I wanted. It used Markdown properly. It provided the tool calls. So everything looks good. I tried enhancing this further by using DuckDuckGo as another tool in a multi-agent way implementation, but once again couldn't do it because of the OpenAI API key issue that I was facing. But check out the video if you guys want to learn more on how to do this. I'm learning this myself, and I thought it was pretty cool. That's it for me. I'll catch you guys later.